In the state's lottery, you can bet $5 by selecting 3 digits between 0 and 9 inclusive. If the same 3 numbers are drawn in the same order, you win and collect $800. Complete parts A through E. Now for part A, it says how many different selections are possible. So it says by selecting 3 digits. Now the multiplication rule states that for a sequence of events in which the first event can occur n1 ways, and the second event can occur n2 ways, and the third event can occur n3 ways, and so on, the total number of the outcomes is the following: n1 times n2 times n3. So we want to select 3 digits. So that means how many numbers are in the digits from 0 to 9? Well, we know that there's 10. So each of the 3 digits can be any number from 0 to 9. So there are 10 possible outcomes for the first digit. And since each digit can be any number from 0 to 9, each of the 3 digits has 10 possible outcomes. So you're going to apply the multiplication counting rule to determine the number of different selections that are possible. So 10 times 10 times 10 is going to equal 1,000. Thus, 1,000 different selections are possible. Now the next question says, what is the probability of winning? Now the probability, or the probability of A, of an event A, can be found using the formula below. The probability of event A is equal to the number of ways A occurs divided by the number of different simple events. Now there is a 1 winning 3-digit selection, so we're going to use this to calculate the probability of winning. So the probability of winning is equal to the number of ways to win, which is 1, over the number of different selections possible, which we found in part A, which is 1,000. So therefore, the probability of winning is equal to 1 over 1,000. In part C, if you win, what is your net profit? Now, to find the net profit, if you win, you subtract the amount needed to play the game from the amount you collect if you win. Now, the prize is $800, including the $5 bet. So let's determine the net gain. Well, if the prize is $8 and you put a $5 bet, you need to subtract that $5 from the $800. So 800 minus $5 gives us $795. So therefore, the net gain would be $795. Now in part D, it says, find the expected value for a $5 bet. Now, the expected value of a discrete random variable x is denoted by E, and it is the mean value of the outcomes. So E is equal to the mean, which is also known as mu, and E can also be found by evaluating the sum of x times the probability of x, where x is going to consist of all possible events, and the probability of x is the probability of each event occurring. Now, we want to calculate the probability of losing the lottery by subtracting the probability of winning from 1. So if we take 1 and then we need to subtract 1 over 1,000, we know that 1 is a fraction is the same thing as 1,000 over 1,000. So 1,000 minus 1 is going to give us 999 divided by 1,000. So now what we're going to do is we are going to then use and create a table to find the expected value. So we have the event, so you have either lose or the gain, which is the net, and then you have the total. And then we have x. Well, what x represents? Well, if you lose, that means you're going to lose the $5 that you bet. Now, what is the probability of that? We found the probability in the first part, or the second part, excuse me, was 999 over 1,000. So now we need to take this x and then multiply it by this probability. So we're going to take -5, we're going to multiply it by 999 over 1,000, and therefore 5 times, well, 999 over 1,000 is the same thing as 0.999, and therefore when we multiply those together, we get -$4.995. Now, what is the gain net? Well, we saw that the net gain was $795. And we want to find what is the probability of winning. Well, the probability of winning was 1 over 1,000. So now we're going to take the value of x and multiply by its probability. So we know that 795 times 1 over 1,000 is going to give us the following. Well, we got 795, and we know that 1,000, 1 over 1,000, the same thing as a decimal, is 0.001. Multiply that by 795, and then we get 0.795. Now, the expected value is adding these two amounts in this column. So, to find the expected value E, we're going to find the sum of this column. And so we know that the first number was negative 4.995, and then we're going to add 0.795. When we add them together, we get negative $4.20. Therefore, the expected value is negative $4.20. Now for part E, it says if you bet $5 on a certain casino game, and the expected value is negative 4.1 cents. Which bet is better in the sense of producing a higher expected value? A $5 bet in the state's lottery or a $5 bet on the casino game? And explain. Well, we're going to compare the expected value for the state's lottery, which was found in Part D, to the expected value for the casino game, which is what was given in Part E. And then to make this comparison, first convert the value from Part D to cents. So we have negative $4.20 is equal to negative 420 cents, which you can see is a lot different than negative 4.1 cents. Therefore, we would say that the casino game is a better bet because it has a larger expected value.